Alright, so this could be my explanation of one of the problems from your lesson 4.3 homework. It's in that the homework you're assigned is on page 304 and 305, I think. But these two problems you have to do are on page, or the problem number 8 and 10. That might be 305 or 306, but it's right around there. But these are problems where it gives you two triangles, and it asks you, it gives you the points on the coordinate plane, and it asks you, are they congruent triangles? And there's a couple things we can do. Let me move this out a little bit to determine that. We're going to go over that right now. Let's fix that. Okay. So the first thing you can do is you just graph them, right? So you graph them, and sometimes if you just look at the 2 points there, they're on the coordinate plane, you can see, yeah, they're obviously congruent triangles. And then just looking at it. So, but you can also look for transformations. So if you had a triangle that was reflected on the x or y axis, you could see that they are congruent. Or you could see if it was rotated 90 degrees or whatever, and you can check the points by doing that. You could also see that they're congruent triangles, because eventually it could slide right into place. Okay. Well, if those two things don't work, and we look at these triangles and we probably think, they don't look congruent to me. But you should always double check. And one way you can do that is by checking the length of each side and seeing if they are equal to each other. And we're going to do that now. We use the distance formula. We haven't used that for a while, but we did use that when we were looking at lines and angles. And the distance formula says if you wanted the distance between 2 points, and we could just say E and G is a point. We could say E and F is a point right here. We could say F and G are a point, and then see if the total distance around equals the same as the other one as well when we do the same thing. So we're going to start by using this formula. So we'll say the distance of, we'll just go this line right here, AB. Okay. And we just need the x's and the y's. So we're going to go back, and if we can actually put these points in. A looks like it's 1, 1. B is equal to 0, 3. And then we're going to plug those in. So x2 was to say this one's 0 minus 1 squared plus the y's are going to be 3 minus 1, 1 squared, 1, 2, 1. And then we just do the math. We're going to get the square root. It's negative 1, but it's going to be squared to be 1. And it's going to be 3 minus 1 is 2 squared. It's going to be 4. So it's going to be the square root of 5. That's AB. Then we do the next one, B and C. B we already have. C is going to be, if we look at the graph, it's going to be 1, 2, and then 1, 2, 3, 4, 5, 2, 5. That's its coordinates. Then we'll do the x again. We'll use this one. We're comparing it to B. So 2 minus 0 squared. Add that to the y's. 5 minus 3 squared. And that's going to give us, again, 2 minus 0 it's going to be 4. Plus 5 minus 3 is 2. That's going to be 4. So it's going to be square root of 8. And then we're going to get this. Oh, I'm sorry, I didn't show you that. You can see that there. And we'll just continue. I'll make sure you can see this. So then we have AC is our last point. Doesn't matter which direction you go. It could be CA. So then we do, we'll do C again. So we'll do the x first, 2 minus 1 squared plus 5 minus 1 squared. That's going to give us the square root of 1 squared is 1, because 2 minus 1, 1. And then 5 minus 1 is 4 squared, 16. Okay? And then we will end up with the square root of 17. Okay? So that's our first triangle. We do all that math there. I'm going to move this back just a little more now. Okay. Just give you some more room so you can see it. So this is this top triangle. So then our next step is to do the calculations on the next triangle. And I'm going to stop the video, do the calculations, and then come back and show you my answers. Okay, then you can see I did the math already here, just to, so we don't have to put that in the video. But you remember if I did this first one, so 5, square root of 5, square root of 8, square root of 17. And we're just doing the distance formula from up here. We're just doing x squared, x2 minus x1 squared plus y2 minus y1 squared, the distance formula between 2 points, using that from a triangle. And we do this on this one, so we do the point EF right there, and we get, in the end, we get square root of 17, and look, square root of 17. So maybe we're wrong. Maybe this is congruent. And then we look at EG, and we get square root of 18. We look over here, there is no square root of 18. That tells us not congruent. And we'll just talk about that y in a minute. And then we have this one here. It's a square root of 5, and it matches. So we got a square root of 5, and a square root of 17, but the square root of 8, the square root of 18 do not match. So this is not congruent. And the reason we're basing that on is the side theory. So if triangles have 3 sides that are the same, they're congruent. This only has 2. One side is not congruent, so they're not congruent triangles. So that's an example. I think you could do the other ones in your homework. Let me know if you have any questions.